to identify data analysis tool to be used in your research process, no? Or in analyzing your research results. Now, in this case, the first factor that you need to consider is the study objectives. Okay, take note, your study objectives is framed, all right, during your proposal stage. And in your research, okay, in your research subject, you were able already to come up with your proposal. And that proposal, okay, will be adapted for you to conduct your research. Now, if you are going to consider a data analysis tool, you have to go back first to your study objectives. Okay, as we go through, I will illustrate how the study objectives will be the basis, okay, will be considered in identifying your data analysis tool to be used. Another factor to be considered is the type of variable being analyzed. Now, yesterday, I'm listening to your Sir Arman, all right, Sir Arman rather. Your Sir Arman said that there are different types of variables. So he emphasized the quality, quantity, and of course, in our journey, also in the data processing stage, you need to consider how you define these variables, no? And I told you, when you define variables, you will not just operationally define it. There are three ways to define variables. Okay, what are these? You have to define, all right, the variables conceptually, operationally, and analytically. So, well, I think that was discussed yesterday, all right? And in the choice of your data analysis designs or data analysis tool, you will not just consider, okay, the objectives or the type of variable being analyzed, but also what study design did you adopt? Okay, so it pertains also on the nature of the study designs, okay? Whether you made use of descriptive or experimental or cross-sectional or observational. Now, definitely the study designs were discussed in your research, okay? And then you also have, all right, you also have the so-called number of variables included in the analysis. Now, you see, this factor is very important because you are not supposed to just identify, ma'am, gagamit daw kami, so we will use Chisquare here, we will use ANOVA here. It is not like that. You need also to consider, okay, how many variables did you include or will you be including in your analysis? And also, okay, the sample size you have used. Now, yesterday, your Sir Arman emphasized, okay, how to compute for sample size. And take note, no, in the data analysis, there is a difference between t-test and z-test. For large samples, we're going to use the z-test. For small samples only or not so large samples, you use t-test, something like that. So as we go through, I'm going to discuss all these things, no? And then you have also to consider the extent to which usual requirements for the valid application of parametric tests are to be satisfied. All right, these 6 factors, okay, that you need to consider are to be what? To be paid attention first before you will what? You will adopt a certain data analysis tool. Now, let's have an example of how your objective changes your data analysis. For example, okay, I have here set of questions, okay? Now, what data analysis tool to be applied? For example, you are going to answer a question of what are the mean birth weight of babies born from teenage mothers. Okay, there are 3 age groups here. We have birth weight, of course, your birth weight of babies born from mothers with ages 20 to 34, and of course the late, okay, those parents or those mothers or those moms who will bore children or babies at late age 35 to 49. So here, the statistical tool to be applied is definitely the estimations of three means. No? But if you're going to test the hypothesis already, okay, and you will ask the question, are the mean birth weight of moms, for example, all right, differ? Okay, so is there a significant difference on the mean birth weight of babies born from the different age groups of moms that you have identified? So you see, okay, from this, you specified already your variable and you specified the age groups, and this is seen in your objectives. You are very clear of what statistical tool will you adopt. Okay, and then you are right. For example, you talk about prevalence. Okay, prevalence of low birth weight among the teenage mothers. Actually, this study, we are going to conduct this study with Ma'am Vilma. No? So I am now framing the. Okay, I have finished already the proposal for this. I'm going to let Ma'am Vilma check, and then we're going to submit this. No? So this is actually our study. So you talk about prevalence of low birth weight among teenage mothers, and then among those mothers, okay, whose ages are 20 to 34, and then those mothers whose ages are 35 to 49 years old. But take note, again, you talk about estimation of proportions because you talk about, all right, the prevalence of low birth weight. So what statistical tool is applicable here? You're going to measure the three proportions of these three age groups of mothers. But then you need to test the hypothesis later, and you will use now, okay, z-test to determine if the proportion is significant. All right. So this is how your objective changes your data analysis. So the data analysis actually is dependent on your objective. So this time I want you to realize that whenever I will not answer your messages from me, because there were several of you, right, who are messaging me asking for a statistical tool to be used, I am not answering. I will just ask you to send me your objectives. But then even if you have sent your objective, all right, it is not enough because there are other factors that you need to consider. Okay, let us see another thing here in the framing of objectives. So your objective definitely is anchored, okay, on what? On how you are going to analyze later. Because take note, the research objectives are the steering wheel of your research. So, kumbaga, ito yung direction ng gagawin mo. So, in this case, all right, let us have this example. We talk about the type of data. No? So, if the objective is birth weight of the child associated with the age of mothers upon giving birth. For example, that is your objective. Okay, take note, you will not ask me again, Ma'am, what is statistical tool? I will again ask you, what is the nature of your data? So if you're going to gather qualitative data, which was discussed, okay, by Sir Arman yesterday, okay, there are two types, no, the quali and the quantitative data. So if you will gather only, all right, qualitative data, which means that you will have to group the ages of the parents. So you have three groups of moms, okay, mother's age, no, mom's age, and then you will just count how many of these children were born. Okay, definitely you have to gather that in a scientific sampling so that you can test the hypothesis. But if you did not, okay, if you have made use of non-probability sampling, then you don't have the right to hypothesize your study. So in this case, all right, let's be sure of that. Take note, hypothesis is only given for those, all right, researches that made use of probability sampling. No? So if you did not use probability sampling, you don't need hypothesis anymore because that is non-scientific. So only when, all right, you made use of probability sampling that you can hypothesize your study because you generalize it to the entire population since you made use of scientific sampling design. So in the event that you will answer this question and that the question is actually to be answered about association, the analysis tool is dependent on the nature of the data. So if you made use of qualitative data, you gathered qualitative data, then chi-square test of association is being used. But if you make use of quantitative data, then you are going to use the correlation coefficient, the Pearson correlation coefficient, and you will test the hypothesis using the t-test. No? So you will not just find the correlation coefficient, analyze the correlation coefficient, and then you're going to test the hypothesis if and when you have gathered the samples in a scientific way. All right, so you make use of the test. Now, we go further. For example, you change your, you have another objective to answer. Is age of the mother upon giving birth a predictor of the birth weight of the child? Now, this time, you talk about predictor variable. In this case, you will analyze the results using regression analysis. All right. Age lang naman siya, so simple regression lang yan. Okay? So only one predictor variable, which is just a simple regression. All right? Are you there? Is there any question? So you just tell me if you have questions. Now, another factor that you have to consider is, of course, the way you measure the variable. And we have studied yesterday, I listened to your Sir Arman, he made mention about the different scale of measurements. Now take note, we have the four most commonly used scale of measurements: the ordinal, the nominal, the ordinal, the interval, and the ratio. This will affect your data analysis. So it all depends again, all right, on what scale of measurement you have used in measuring your variables, so that this will again affect your data analysis tool. So in this case, we'll talk, we will have another factor to consider, the study designs. Now, well, the study designs definitely were discussed with you in your research, and there are several study designs, no? So the type of study design will affect your data collection, data analysis tool. So you have to consider whether you made use of observational or experimental, and the type of observation and experimental study being used, no? So meron tayong cross-sectional, we have also we have case control, and so on and so forth. These are all discussed in your research topic, no, in your research subject. So this will affect the way you analyze the data. So we go through afterwards, and I'm going to give you some a summary of certain data analysis tools depending on all these factors, no? Okay, the mode of sampling your participants or your respondents. So take note, this is the sampling design again that you have discussed yesterday, no? So whether you make use of probability or non-probability sampling, or you have also large samples for clustering, and so on and so forth. And then the types of samples, the independent samples and the related samples. Now take note, we have the so-called t-test for independent samples, and then t-test for related samples. Why? Okay, when you talk about related samples, there are several data to be obtained with just a single group. Related siya. So kapag alam nyo na ang related, so if you know already what related samples are, you will come to know what independent samples are. So in this case, when you talk about related samples, you have gathered several data, all right, from a single group of samples. So for example, you talk about the results of pre-test and post-test, and definitely you were given the pretest prior to the online. Okay, for example, I'm going to conduct a study on online, the effectiveness of the online, okay, online delivery of learning. In this case, you have pre-tested those who before, okay, before the online, there's pre-test. After the online, there is post-test. This is an example of related samples. So I took, all right, several data from one group of sample, and that is what we mean by related sample. Okay, so you talk about number of groups being studied or compared. So meron tayong univariate, or right, bivariate, or more than 2 groups. So we have 1 group, 2 groups, or 3 groups, no? All right. Another is, of course, the task, kasi I told you there are 6, and I am all right. I am discussing the 6. So, well, the number of variables included in the study. So, instead of just the groups, you also consider the variable. Now, are you analyzing just one variable, or you're making comparison between variables, or multi-comparison of variables, or several 2 or more variables? So, you have to adapt a certain statistical tool depending on the number of variables that are to be analyzed. And, okay, so we have the sample size. If you are dealing with large samples, then definitely data analysis is also what affected. So there are, all right, there are statistical tools that are usually appropriate to analyze. So take note, my topic is correct analysis tool, which actually is more relevant to say it's appropriate statistical tool. Now, all statistical tools that are offered, you are using, for example, a statistical, okay, a statistical software. The software will just run the statistics for you, but the question is this the appropriate, okay? Is this the appropriate tool that we're going to use, no? So in this case, we talk about the large samples. We will use, for example, if you use z-test for large samples, t-test for small samples, no? Okay. Now, from here already, you see, ay, ganun pala yun. All right, so you talk about the small sample only, so you can use the t-test, especially if you talk about comparison, okay? You do comparative analysis. Now, next, we have the extent to which the usual requirements for valid application of the parameter tests are to be satisfied. So, well, I think your Sir Arman have talked about normality and independence. Now, take note, before you gather the data, you have to assess first the parameter, the population parameter. No? You talk about population. In this case, you talk about test of homogeneity, test of normality, and test of independence. And I think this was discussed yesterday by your Sir Arman. No? So these are the things that you need to consider in selecting, therefore, your data analysis to be applied. Okay. Now, you analyze data because you want to address, therefore, your educated guess, and that is definitely your hypothesis. Now, there is what we call now a hierarchy of hypothesis tests, no? The parametric and the non-parametric. So, well, you were my former students in biostatistics, and I have discussed all these things. I'm going to just, add some more. So in this case, you talk about parametric tests, no? A parametric test, actually, all right, from this hierarchy now, if you see one sample test only, you can use the Z and the T test, okay? Test of one sample or test of 2 samples, you make comparison whether it is, it is actually independent or paired. So you make use of t-test, and you can also use z-test for independent samples, especially if you are dealing with large population. And for parametric, you have the one sample. We normally here chi-square Kolmogorov, run test, binomial test. These are the things. So as we go through, you will learn all this. No? Now, let us see first, when you talk about parametric and non-parametric, no? When can we say that our study needs to be applied with a parametric test, or when can we use the non-parametric test? Now, I made a table here, a cross tabulation of the differences on the parametric and non-parametric, so you will already be having a basis, no? So that you will be guided, because in our workshop afterwards, I will ask you to identify, okay, the appropriate statistical analysis tool that you adapt based on, or that you will use in your study based on how you frame your objectives and based on the different factors that we have just discussed. All right. So when you talk about parametric test, no, this is a test in which specific assumptions are made about your parameter, about the population. So it is actually based on how you are going to identify the assumptions about the population. So it is important that as early as data gathering, you know already the nature of your population parameter, and tests of independence, tests of normality actually are needed. So you have to assess. Okay, and this was discussed yesterday by your Sir Arman. No? So when do we use therefore parametric? When you have an assumption about the parameter, about your target population. So well, when we were in biostatistics, okay, I told you you should know your target population and the difference between a population and the target population and a sampling population. So I specified that. No? So in this case, you should know the nature, and you will now make an assumption that this population actually is carried out with what? A normal distribution and everything. So there are assumptions of different tests. And as we go through, I will give you the test statistics and the different assumptions, okay, that you are supposed to meet so that you can use this test, this analysis tool, no? All right. But when you talk about non-parametric, this is a statistical test used in case of non-metric, no? All right, independence of variables. So in other words, you can, okay, you cannot come up with an assumption of how this population, okay, you gather the data in, okay, in a manner that you made use of scientific sampling, but then you cannot make an assumption. So you were not able to meet the assumptions that are supposed to be set using a certain tool. Therefore, you will use the non-parametric. Now, let's talk about the basis of the test. So if you talk about parametric, it is a distribution test. All right, take note, there is T student distribution, there is Z student distribution, there is a normal distribution. We have the, okay, the Gaussian distribution, the Gaussian curve. In this case, all right, if you are talking about the distribution and you have analyzed the test of homogeneity, a test of, okay, of the arbitrary test, no, the test of independence, in this case, you were able to define that this population has a certain distribution to define. In this case, you can use the parametric test. But if it is arbitrary, then it is non-parametric, no? All right. Now for the measurement level, so you have the different scales of measurement. I have discussed this a while back, and I think that was also discussed yesterday. So there are four scale of measurement. The most commonly used scale of measurements, the scale of measurement that you use in gathering your data is interval or ratio. So if you make use of ratio or interval in gathering your data, then use parametric. But if it is a what? A nominal data or an ordinal data, then you will use the non-parametric. So you see now, no, these are the factors. It is very important. You just remember all the 6 factors so that you will see whether this analysis tool that you will use or that you will adopt is appropriate for you to, okay, to use in your research, no? Okay, then if you are going to describe, so you talk about descriptive statistics and you made use of mean as your measures of central tendency. Okay, so mean of inhibition, the mean, okay, mean, yeah, ano pa yung mga mean? Okay, mean age and everything, no? So, mean salary. So, you have analyzed the central tendency. You have summarized the data using mean parametric test. But, if you made use of median, okay, the measures of position in central tendency, you can use now the the median test, which is the non-parametric in itself. And don't you worry, this non-parametric and parametric tests are all in the software. So you can use the Stata. Well, Stata or SPSS, there are parametric tests there are non-parametric tests. But as to the question of the applicability, whether this is what you use, then you should go back to the 6 factors so that you will see whether it is applicable or not. No? So it's a question of applicability of a certain research. Now take note, doing a research actually entails large sum of money. Okay, but I keep on saying you can lie to others but not to yourself. In this case, the rule of thumb in research is you can lie to others but not to yourself. You might say, well, I am completely aware of the information about the population. So completely known. In other words, if the information that you have about your target population is completely known, then you can use parametric. But if the population, okay, if the population where you gathered your data, right, is unavailable, then it is non-parametric, no? And then we have the so-called arbitrary, the so-called applicability. So if you make use only of solid variables, all right, variables that are measurable in terms of ratio and interval, then it is parametric. But if it is variables that are considering their attributes, the measurement at the same time their attributes are being measured or are being described, in this case, you make use of non-parametric. All right? So you make an association. For example, you're going to test whether there is a significant relationship, there is significant association, and you are going to use Pearson for parametric, but Spearman for non-parametric. All right. Take note, you might say, ma'am, is there a difference when I made use of Spearman, but the thing here is it is supposed to be Pearson? There is a slight difference. Though I want to make you realize, okay, that Pearson is used when you're going to test if there is significant relationship, which actually, all right, are measured based on ratio. The variables are measured based on intervals or ratio. So these are actually numbers in nature. But for Spearman, you will rank the situation, okay? Now, there are some equivalent tests. No? So, ma'am, you're talking about the differences between parametric and non-parametric. How do we now determine what tests are to be used whenever it is parametric or non-parametric? So, these are the equivalent tests. For example, you talk about independent sample test. Okay, independent sample t-test. So, that's parametric in nature. But the equivalent of that, all right, in the event that the population is completely unknown, the information about the population is unknown, definitely you can use still man-with-me test, no? Man-with-me, because you did not test the independence. You did not test whether it is homogeneous or heterogeneous. Okay, you did not test the test of independence or the test of homogeneity of the population. In this case, okay, you can use non-parametric, and that is the equivalence of the equivalence of t-test. The t-test for independent samples is actually man-with-me test. Okay. Then for paired sample t-test, the equivalent of that is the Wilkinson signed rank test. Okay. So paired t-test siya because it is related samples. So you gather data and this is just taken from one group. For example, you are going to on the effectiveness of certain nutrition program. Okay? So prior to the, all right, prior to the giving of the program, all right, you have already tested or you have measured the nutritional status of the recipients of the program. And then after 6 months giving the program, okay, you will see or determine, this is the point why statistics is very, all right. The thing here is the answer of our queries will always be done statistically. So we always say, it's obvious naman, gumanda ng buhay nila. But is that significant? Okay, yung pagganda ba ng buhay nila significant? So baka gumanda yung buhay ng 2 o 5 o 10 lang. Alright, yung iba, so gumanda ba talaga ang kanilang status? So that's the reason why we need to prove it using statistical process. And so after 6 months of giving the program, for example, and that actually you need still to evaluate the status of the recipient of the program. But take note, all right, there are variables to be considered there. There might be what? Intervening variables. There might be, okay, other variables that can affect the nutritional status, no? So you have to consider, no, those things. No? So we have the Wilkinson rank test is also used whenever you make use of what? Of non-parametric test. In one-way analysis of variance, well, there is Kruskal-Wallis test. So you made use of non-parametric, pero ma'am, ANOVA pa rin yun, non-parametric pala. Ma'am, ano yung Kruskal-Wallis? Kruskal-Wallis test is an equivalent of ANOVA, okay, analysis of variance, whenever you are what? You are using, therefore, non-parametric, no? So we have one-way repeated measures of analysis of variance. Kung one-way siya, alright, pero it is repeated analysis is done. Therefore, there is another equivalent for that. That's a Friedman ANOVA. Okay, any question? Now, may we see therefore some assumptions of the test? So, because we talk about when to use the t-test and when to use parametric and when to use non-parametric. Now, take note, okay, that you will not just adopt a certain test. Okay, you should meet certain assumptions, assumptions so that you can adapt the test. So these are the assumptions, okay? This, when you say you assume, it means that you made an evaluation, no, of your population parameter. In other words, what's the condition of your population? And therefore, from this, you should meet this assumption so that you can use the t-test. So what are the different assumptions for the use of t-test? Am I audible? Are you still there? Okay. So, hello. So in this case, all right, the population is infinite and it is relatively normal. So when you say relatively normal, well, we discussed the test of normality, the Gaussian curve, no? In this case, I know that you are very familiar sa characteristics ng normal curves. So what are the different characteristics of a normal curve? So the population should be infinite and it should be normal. And that the population variance is unknown and estimated from the samples only. So that's the reason why there is test of independence and test of normality, no? And the mean is known. So you know the mean. Definitely test for T, okay, is used when you make a comparison of the mean. So these are the assumptions that you have to satisfy so that you can use the t-test. And then sample observations are random and independent. In other words, okay, you can use the t-test if, take note, if the samples are selected in a scientific manner, or we call that as probability sampling. And all right, the sample size is small. So you have to use t-test for small samples And for z-test, you have to use z-test for large sample. And then your null hypothesis can be one-sided or two-sided, or we call that as directional and non-directional hypothesis. So it all depends on how you stated now your hypothesis in your research question. So in this case, whether it is a one-sided test or two-sided test, you can still use the t-test. Okay, so these are the different assumptions for t-test. And the most commonly used, okay, what I am giving only are the most commonly used statistical tests, no? All right, so now let's go to one-way analysis of variance or one-way ANOVA. So one-way ANOVA is actually to be used only if you satisfy the following assumptions. So these are the assumptions that you should evaluate, okay, that you should know so that you can adopt one-way analysis of variance. So am I audible? All right. One-way analysis of variance should carry out the following assumptions. So there are 5 assumptions, no? Normal ang distribution. So we have normal distribution of the population from which the samples are drawn. In other words, you make use of
Yes, Ma'am Lars. Nawala ka po.
hello? Hello?
Yes, Ma'am Lars. We can hear you already.
Okay. So, bakit nawala? All right. So we have, okay, we have those following assumptions, no? Another is, of course, all right, the distribution or the population should be homogeneous, and you should know the population variance, no? So those are the assumptions that you have to satisfy so that you can use one-way analysis of variance. All right. Now, if there's one-way analysis of variance, there's also two-way analysis of variance, no? Okay, now afterwards, I will make a description of when to use one-way and when to use two-way. Normal distribution of the population is also to be observed whenever, okay, you make use of two-way ANOVA, no? Take note, ha? All right, you have to assume that it is normally distributed, but it is not done like that. You notice that, okay, your Sir Arman yesterday, okay, will or have asked you to come up with pre-testing your samples, your data collection tool, and your data collection tool will be used to determine whether the population parameter is homogeneous or not, no? Or it is normal or not. And then it's not only that, because there are so many reasons why you need to pilot test your data collection, no? Then the measure of dependent variable and the independent variable should be continuous. Okay, the dependent variable are at the continuous level. In other words, there are 2 types of quantitative data, no? The discrete and the continuous. So if you made use of a continuous, continuous data, then and that your dependent variable is also measured based on the on the continuous data, then you make use of two-way ANOVA. And then you are comparing, okay, more than 2 or more categorical independent groups in 2 factors. That's why it's two-way ANOVA, no? All right. And also, okay, categorical independent groups should have the same size, right? And independence of observation is also observed, and definitely, or it is supposed to be assumed to be independent, no? And then homogeneity of the variance of population is seen, no? So, well, test of homogeneity should be done so that you can, especially if you have pilot tested your data collection tool, so that you can say na I can adapt this particular statistical analysis tool. All right. Now, analysis of variance is data analysis tool, no? But you are supposed to test if the variance is significant, no? Okay, by the F-test. So it is not enough. So especially if you're going to run already, there's an F value. So using now your software, the F value will be coming out after you have already run the software, process your data and run it using a certain software. So the F-test will come out. But when do we use the F-test? All right, again, take note, it should be approximately normal. So the population is normally distributed or approximately normal. Right, then samples have been actually drawn randomly. So I emphasize that, no? Now you are using a lot of statistical tests, and then you are saying that you have taken it, you have taken the entire population. It's a total enumeration. You don't have the right to test anymore. Okay, don't test anymore because it's a total enumeration. And these tests are used only when you have randomized, when you have taken samples only, no? So those of you whose studies are total enumeration, no more test of hypothesis. You should not hypothesize anymore, no? Okay, I read that yesterday in the GC. All right, observations are independent, and your null hypothesis or HO may be one-sided, or it can be two-sided also. So one-way or two-way, one-sided or two-sided, it's directional or non-directional. Now, a lot of students are confused, a lot of us, no? Okay, are confused of when to use the one-way ANOVA and when to use the two-way ANOVA. You know, when I was asked by your ma'am Ikay, no? Sabi niya, can we conduct this training? And then I was approached, okay, by your Sir Eman, ma'am, which one do you prefer? Okay, I prefer the data analysis na lang. So statistical data analysis. All right. And I'm thinking of what to give because, you know, when I saw my audience, I already have a thorough discussion of all the statistical process with you. So this is actually a additional, no? So we were not able to come up with the differences, okay? And that's why I'm focused today of what is the difference between one-way and two-way and when to use such. So let's make a comparison. So this is what I have done now, right? I thought of coming up with comparisons, no? What is the essence of using one-way and what's the essence of using two-way? Okay, so when you say one-way ANOVA, right? One-way ANOVA is a hypothesis test used when you're going to see the equality of three or more population. Take note, ANOVA is analysis of variance, and this is used only when you have more than three, okay, three groups, no? All right, three or more population means simultaneously, and you are going to measure its variance. But two-way ANOVA is actually a statistical tool, okay, used wherein there is an interaction. So three or more din siya, all right? But there is an interaction between the factors influencing the variable being studied. So in other words, you make use of two-way when you want to see, okay, if there is an interaction. Afterwards, I will give you an example kung may time pa. All right. So in this case, two-way is used. Now, One way is used if you are dealing with independent variable that is only one. Iisa lang ang independent variable mo and therefore one way ang gagamitin. Alright? Two-way is used if you have two independent variables. Alright. And you compare 3 or more levels of one factor only one way. So you are now making a comparison of 3 or more levels of one factor variable lang. Okay, for example, mamaya, magbigay na lang ako ng example mamaya. Okay, next, you talk about two-way. The effect of multi-level of two factors. In this case, all right, there are two factors being compared. All right, there are multiple effects of two factors. No? Okay, so next, number of observation need not to be the same in each group. But here in the two-way, dapat magkapareho. So for example, need to be equal in each group. For example, you are making a comparison between or which one is more effective, the synchronous or asynchronous, something like that. All right. And you got 50 students, all right, who are enrolled in the synchronous or who adopted the synchronous, and then 50 students who adopted also asynchronous, make a comparison, right? In this case, equal dapat. And another is, of course, 50. There should be an equal, all right, this equal number of respondents or number of subjects in its group, two-way siya. So take note, my dear, appropriateness is important. Okay, appropriateness of statistical tool. Remember, it's a very, very tedious part of the research process is the data collection. You have done it properly, you have gathered it using a precise manner, and then you have organized it. If you did not use the appropriate statistical tool, it is all coming into waste. No? So, sayang. Okay? Next, design of experiment is to be considered. No? Here, when you talk about one way, you need to satisfy only two in the design. But for two-way, all three principles needs to be satisfied. So these are the differences between one-way and two-way. All right, take note, all the three principles are being satisfied. Now, I want to repeat, no, there is no three-way. There is only one-way and two-way ANOVA. Huh? Okay, any question? None. All right, now let's talk about the F-test versus the T-test. Okay, so this time, you all know that, okay, there are test statistics that are to be used depending on the, okay, on the considerations that we made, okay, on the different factors, no? So the most common is t-test. T-test na lang, mag-pair t-test ka na lang. So it is not like that, no? So you should know why, and that actually should satisfy the assumptions and the different factors. All right. So let's make a comparison between t-test and f-test. Okay, when you say t-test, t-test is a univariate hypothesis test. All right, that is applied when the standard deviation is known and it is used for small samples. So paulit-ulit, t-test because it is small samples. But I saw a certain study, they made use of t-test and they have used a huge number of samples. All right, so it should be z-test. No, anyway, that's the point. Anyway, appropriateness. Then we have F-test. F-test is statistical test that determines the equality of the variance of the two normal population. Now, you talk about variances this time because, okay, when you talk about t-test, comparisons of mean. All right, it's a univariate test. So here, it is a test that will determine the equality of variance. Kaya nag-F-test ka. Now, take note, analysis of variance is ANOVA. It is coupled now with F-test. Okay, next, you talk about, all right, you talk about test statistic, okay, the t-test allows or follows t-student distribution, no, under your null hypothesis. But your f-test will make use of the, okay, Snedeker F distribution, no? Okay, this is under the null hypothesis. So what you are going to see there in the F value is actually generated by the software. But what is that F value that you got? You got that from the what? From the F student distribution, depending on your set margin of error. Okay? Then we have also, okay, the application. When you compare means, all right, you compare means, then you have to compare means of two population, t-test. But comparing two population variance, you make use of f-test. But then, all right, after you have analyzed your ANOVA and there is f-test that is done, okay, here variances are being compared, and that you have found out that there is significant difference. You need to see, right, which of these variables made it different, is significant. In this case, you have to come up with post hoc, and in the post hoc, you will make use of t-test, okay, per t-test. Now, one of the most commonly used tests also is the chi-square. So these are the different, all right, chi-square is one of the most commonly used tests, no? Especially for what? For interval data, okay, or nominal data, no? So in this case, you make use of chi-square test. Chi-square test is a test that measures how a model compares an actual observed data. In other words, meron tayong 2x2 square and so on and so forth, no? So your chi-square symbol is parang x squared siya. That's the chi-square symbol. It is a measure of the difference between the observed and the expected. Okay? Observed minus expected all over the expected. Then you are going to square it. So definitely that your outcomes of the set of events will be identified based on the enumerated data only. And can you see now the differences? Yes, you can. No? So afterwards, I'll give an example. Okay. Now, your chi-square depends on the size of the difference, all right, between the actual and observed values and the degrees of freedom and the sample size that you will use. And the chi-square can be used to test whether two variables are related or independent from one another. So ano nga ba ang alright, ang iti-test natin when you talk about chi-square? So you talk about whether those variables are related or independent from one another, or to test the goodness of fit. That's why chi-square is known to be a goodness of fit test. Right? This is seen between the observed distribution and the theoretical distribution of frequencies. Now, when do we use chi-square? Okay, chi-square is actually a test, all right? Chi-square test is actually used whenever you meet such assumption. There are only 3 assumptions, no? Okay, the data used in calculating a chi-square must be randomly drawn. Again and again, it is all seen in the assumption that all the test statistics are only used when you make use of probability, or we call that a scientific sampling. So do not say na enumeration data, it's a non-parametric, hindi ako probability sampling. All right, in this case, you cannot use chi-square. Again and again, all tests, okay? All statistical tests is used when you have drawn your data from okay, samples, but definitely it should be scientific sampling design, or we call that as probability sampling design, no? And then it should be mutually exclusively drawn from independent variables, and sample size is large enough to base. So there should be a sufficient sample, no? So these are the 3 assumptions that you should satisfy so that we can use the Chi-square test. All right. Now, let us have an example. So this is an example that will illustrate our chi-square. Okay, for example, a 314 CSU CAS students, no, was asked if they have ever taken an online course. All right, we want to see now if there is a relationship between gender of students and the choice of online course. So their genders were also recorded, and we come up with a contingency table below. So I will have to give you the contingency table below. But what we want to see, to test is, we are going to test whether there is a significant relationship of gender. Okay, all right. So we want to determine, all right, we test the independence to determine if there is a relationship between gender and whether or not someone has to take an online course. All right, so this is, for example, the result. So you just ask, all right, 314 students, so all right, randomly taken, all right, and these are the results. So you have divided it according to the gender, so according to sex, rather, men and women, and so, all right, we come up male or female. So we come up with the responses. It's just enumeration data, chi-square. Okay? So there are 43 men who said they have taken online course, and there are 63 did not take an online course, and so on. So this is the data that you got. All right. So it's not enough that you just presented this. So you will now analyze your data using chi-square. Okay. So what should be your basis? So definitely you should come up first with your hypothesis. What is the hypothesis? Why do we need to analyze? Because we need to address our educated guess. So what is your hypothesis? There is no, ay, nagkamali. Okay, so you'll test whether there is no relationship between gender and whether or not someone has taken an online course, no? Right. Or the choice of the mode of delivery of online. So in this case, your alternative hypothesis is there is no relationship between gender and whether or not someone has taken an online course. So from here, you can now have all right, you should now add the row total and the column total. So your row total for men is there are 106 men that were surveyed randomly, and there are 208 women that were surveyed randomly also. So the total is 314. But you notice that there are 138 who have said that they are okay, who have responded yes, and 176 who have responded no. So from here, you will now compute the expected. So we have to compute the expected. Well, you may not do it manually. You can use the software that we have, but I did it manually. Okay, I just presented the values there, right, for you to have an expected value. So from the formula of chi-square, you can solve now the expected. Okay, your expected values are to be computed, and that's why I have stated it here in the second table, no? And employing now the chi-square value, you can do it manually. It's very simple, no? So your formula is observed minus expected all over the squared all over the expected, and the expected can be computed using the values that I have identified. Okay, then you have to consider your degree of freedom. The observed values will be your actual data, and the expected values are to be computed using the column total times the row total divided by the total number of respondents, and that is expected, no? That's the expected values. And using now this formula, as you have seen in the table, okay, a while back, all right, you have all the expected values here, and then you'll just implement it, and we derive with a chi-square test value of 0.743. Now, in this case, this is not enough. This is the analyzed value, but you are going to compute for the, okay, for the degree of freedom, or apply now the degree of freedom using the chi-square table. And that you have the df of 1 because you have, okay, observed minus, we have two variables. We have n minus 1, okay? And therefore your df is 1. So here, you can now see the probability value using the chi-square table. And the probability value, right, is actually illustrated. I got the illustration here so that you can see the area in the chi-square distribution. So we have the probability value is at 0.743 is 0.388. Now, what do you need to do? So you will not just analyze, but you need to interpret, no? Okay, you make decisions, and therefore, all right, what we have studied last time when you have taken biostatistics, if your alpha, okay, if the probability value is lesser or equal to alpha, therefore you are supposed to accept the hypothesis. So since the probability value that you got there is 0.38, it means therefore that whatever margin of error that you set, if for example you set a 0.05, right, which is actually greater, your alpha is 0.05, your probability value is greater than alpha, therefore you are supposed to reject, okay, to accept the hypothesis. So you fail to reject the null hypothesis. But you will not just what? You will not just say, okay, null hypothesis is accepted. All right, it means that, okay, you go back to your hypothesis. Now the hypothesis that you have stated is there is, all right, there is no relationship between gender or between sex, no? And whether or not someone has to take an online course. So that is your hypothesis, and therefore you have to explain or state your conclusion based on the real the real world statement, okay? The real meaning of what you have studied. So there is no evidence that gender and whether or not an individual has completed an online course are related. Right, so take note of that. You will not just conclude using, all right, now there is no significant difference or there is no significant relationship. It's not like that, okay? So that's the point. Now you have to state, therefore, your decision or your conclusion based on the meaning of how you have, or based on how you have stated your hypothesis. All right. Now, some examples here so that you can align it to your objective. So we have here certain tests to be used, all right? If, for instance, that you're going to set an objective and then align it to the type of data that you have used or you have gathered. So for example, if your objective, okay, your objective now is to determine the profile of the respondents, okay, or the subject of the study. So that is your research objective. So determine the demographic profile of the respondents of the study, right? In other words, or determine the social demographic profile of the patients in with uncontrolled diabetes. For example, if that is your research hypothesis, now your test statistics tools definitely will just be descriptive, no? So tools in descriptive statistics like frequency count, tables are to be used, no? Histogram, and so on. But if your objective is to, okay, estimate the magnitude or level of certain parameter now, and you are, okay, coming up with a qualitative variable with just one group. So your objective now is to determine the prevalence of smoking among high school students. So what is the objective? Prevalence of smoking among high school students. Therefore, you are going to analyze it using a point or interval estimates, and you are going to measure the proportion. So it is a parametric test, but you have to measure the proportion, prevalence of smoking. Or you have two groups, okay, to determine the change or increase in the prevalence of smoking before and after a certain smoking program or anti-smoking program were introduced. Or in this case, you now make a comparison, so you'll have now a point and interval estimate of difference between two proportions. And this is parametric. You're going to use large samples here because it is a what? Estimation. It is prevalence study. So z-test is used, no? So you will use the z-test for parametric. Or to determine the difference in the prevalence of smoking between students in public and private schools. So, still, it is a parametric test. All right. So, in this case, there are so many considerations that you have to adapt, no? So, take note. Here, for example, another example is, okay, if you're going to determine if the prevalence of smoking and other, smoking among adolescents in Legazpi, all right, and the whole country, so nationwide. Now you gather qualitative variables. So again, you gather a qualitative variables. So you can use parametric test, all right, for single proportion, but since it's qualitative, you have to use the binomial test. Okay, so those are the things that you need to consider. Another is, all right, if you have a quantitative variable, you gather a quantitative variable and you want to determine the mean waiting time. For example, this is your objective. The mean waiting time of patients at the rural health units, okay, differ from those recommended time at most 15 minutes. So there is a recommended time to serve a patient. For example, and you are going to gather quantitative variables. So you talk about z-test for single mean or t-test for single mean if population variance is unknown. So in this case, z-test is used if you made use of a large sample and you are making use of a comparison of mean, but variance are taken from the population. All right? And another research objective, for example, you talk about comparison. All right, compare the prevalence of smoking between male and female high school students in private schools. So again, it is independent sample. You make use of z-test for two proportions, but it is when it is parametric. But if it is non-parametric, it is actually a test of homogeneity chi-square, no? The Kolmogorov Sinov two sample test, Sinov two sample test. Okay, so if you talk about related samples, so if the samples are related, and I have discussed that a while back, right? You are going to have the z-test for two sample proportions, okay, or McNemar's test if it is non-parametric. All right, and okay, last two slides. So for example, another, okay, to determine if there is a correlation between the duration of smoking and the number of cigarette smoked among high school students. For example, that is your objective, and this is a quantitative variable. So you talk about duration in time and the number of sticks of cigarette consumed, for example, by a set of high school students, which are taken randomly. All right, in this case, all right, again, if it is parametric, then you will now have to compute the correlation coefficient using Pearson, all right, to determine the magnitude and the strength of the correlation. That is the R, the Pearson R. But if it is non-parametric, you still can compute for the correlation coefficient because you are asked to determine the correlation, no? Right, in this case, you can use the Spearman rank order correlation coefficient test. Okay, that is if it is non-parametric. But then, all right, in your hypothesis now, if this is hypothesized, you can now compute the test statistics using the t-test, no? Test whether the correlation coefficient is significant. But you can also use the z-test, okay, for greater samples now, or t-test for small samples. Right? Now, last two slides. Okay, to determine, for example, if this is your research objective, to determine if age parity and malnutrition status of the mother are significant predictors of birth weight of a child, for example, or of the child. That is your, okay, that is your variable, or this is your objective, and your variable is quantitative. Then the only way you can analyze this is through parametric. You will make use of multiple regression analysis. Okay, and for example, if your qualitative data is being measured and your objective is to determine if the birth weight and the agar score of the child are significant predictors of infant mortality. This is again qualitative. All right, it's qualitative, but you can use now therefore the logistic regression, multiple logistic regression, but it is parametric. All right, so these are my references. So you can take pictures, a screenshot of the reference so that you can read more about what I have given you today. And may I end, okay, my talk with you, or my lecture with you, by quoting Maya Angelou. I did then what I knew, how to do it. Now that I know better, I do better. So sometimes, this is the usual thing that we usually adapt. Ginagamit natin kung ano yung nalalaman lang. Pero ngayon, at meron tayong bagong nalaman, now that I know better, I do it better. So good luck in your research journey. Thank you for listening and have a good day. So this time, may I ask you, okay, we will adjourn for the afternoon session. We will have our workshop. So what I want you to do is to come up with your objectives. So you have to prepare your objectives with you, identify the variables in each objective, write how many variables and so on. And then from what I have discussed, and also the type of data that you will use, the scale of measurement that you will use in gathering your data, the study design, and of course the sampling design that you have adopt. All right, identify now statistical tool that is applicable for your research later. So we'll see you this afternoon at 1 o'clock. Thank you.
So, yeah, thank you po, Ma'am Lars. So, if the audience have any questions they want to ask now or some clarifications they want to ask, you may ask our speaker at this moment.
May question ako kay Ma'am Lars.
Yes, Ma'am G.
Ma'am Lars, kasi very new sa amin tong non-parametric test. Meron bang mga trainings on this one? In future, para maano kami. Kasi mas ano kami dun sa parametric eh.
Okay, sige. We can, sige. I will ask PSA. Pero ngayon ang deadline kasi.
Kasi like, we know na kapag nominal or ordinal yung mga gagamitin na naming variables, alam namin na hindi kami dapat gumagamit ng parametric test. Pero kasi, yun nga, wala kaming alam about for example, the Kolmogorov-Smirnov, mga ganon. We just know na dapat yun ang test na gagamitin for today kasi yun na-enlighten kami na from your lecture.
Thank you naman. Thank you naman.
Kasi,
so what is Arman here? Is Arman?
Yeah, I think Arman is here po.
Okay. Sir Arman. I think wala siya.
Nag-brown out lang sa kanila kanina, ma'am, pero I think bumalik siya eh, or nag-brown out ulit.
Hello, ma'am.
I thank you, Lord, for not for allowing me to finish my lecture without power interruption. So anyway, yun lang. Okay, anyway, the point here is, Sir Arman, are you here?
Yes, ma'am.
So they are requesting for a training for non-parametric test daw na sabi ni Ma'am Jinky kasi ngayon nga lang daw niya na. Okay, so in this case, I am telling nga na if ever, pero sa dami kasi ng ginagawa, no? Okay? We can ask PSA to sponsor again. Pero ito naman, this is for professionals na siguro.
Yes, Ma'am Lars. Pero most of the, lalo na ngayon na pandemic, they cannot do really data gathering na malaki yung samples and then interval yung mga ano nila, mas actually magagamit nila itong non-parametric. Pero yun nga ma'am, parang if at most siguro like contact persons na pwede nilang makausap for them para ma-assist sila sa pag-analyze using non-parametric statistics po. Kung walang mga antawag dyan, kung wala pang training for this. Pero maganda ito for the National Statistics Month.
Yeah, actually, I am the reason why I'm asking whether Sir Arman is here in the Zoom now is because we can propose, no? We can propose for training again so that it will be formal, no? So we can come up with a training, but this time it will be not anymore the students are not the audience, but instead, or we can invite the students to be participants too, so that we can maximize the training participants. So we will just, siguro most likely we can make a letter. Pero what I know is today is the deadline for the proposals of activities, no, for the celebration of the National Statistics Month, which will be on October. So ngayon, but if ever, then we can still come up within siguro.
Yes po. Yes, ma'am. Thank you po. Yes, Sir Arman.
Ma'am, okay lang, may question din ako. Nilaya po.
Yes po.
Ma'am, narinig ko lang kanina, gusto ko lang i-clarify encounter. Di ba parang nabanggit mo kanina pag total enumeration?
Hindi kita naririnig. Sir Arman, sorry, I cannot hear you.
Hello, ma'am?
Yeah, okay.
Yung pag sa total enumeration, ma'am, parang nabanggit parang hindi na ba kailangan ng H o ma'am na hypothesis?
Yes.
Then, for example, ma'am, ang isang question student is gusto nilang
Total
malaman.
enumeration na nga eh.
For example lang, ma'am, paano natin sasabi, for example, may gusto nating malaman if there's a relationship between, kunwari, age and height.
Hindi kita masyadong marinig kasi, sir. Sorry, I cannot. I don't know if
Yeah, Sir Arman, may parang
sa chat ka na lang.
At ko na lang po, ma'am.
I-chat ka na nga lang.
Oo,
Hindi ko kasi marinig eh.
Okay, ma'am.
Pero I hope na I am audible, no? Am
Yes,
I
ma'am.
Yes, Ma'am Lars. I think Sir Arman dahil nag-brown out sa kanila kanina. While Sir Arman is typing his question sa chat box, others who has a questions for Ma'am Lars?
Yeah, okay. You can ask now your questions.
Clarification before we do para magawa natin yung workshop ng maayos this afternoon.
Bakit ako na-restrict sa sa chat?
Ba't naka-restrict si Ma'am sa chat? Adin, Revita?
I'm pretty sure na open po yung chat box sa lahat po.
Tingnan mo, baka naka-restrict.
Tingin ko eh.
Yeah, opo, ma'am, naka-open po siya sa lahat.
Okay. O sige, okay na. So I cannot hear. I cannot see any question from Sir Arman.
Ayan na po.
Ano, ma'am?
Right. If total enumeration is used, ma'am, paano natin i-identify if just in case ang interest is to identify if there is a relationship between two variables? Okay. So when you say total enumeration kasi, sir, ma-identify mo kung may relationship by making a comparison already without any more testing, because the tests are actually used only for samples. Now, what is test statistics? What are the test statistics for? This is actually a test for us to generalize it to entire population because you have taken samples. The thing here is, since you made use already of the entire population, you make a comparison, and that actually is it's not generalizing. It is narratively coming out with an outcome. Hindi ka na wala nang generalizations kasi hindi ka naman nagsample. Total enumeration ka. Now, in all test statistics contains assumptions that are taken randomly. In other words, you are supposed to come up with generalizations only because you have sampled the data. Ngayon, if you want to show relationship, then you are going to compute for what? Pearson. That's analytical. Pearson, Spearman, and you want to show the relationship and you have taken all the respondents, then that's better. But it is not hypothesized anymore. There will be no more hypothesis. You need not to test whether it is significant because it is already 100%. There is no margin of error anymore because your margin of error is set since you have taken samples, and these margin of errors are already identified by the use of a certain formula in selecting your sample. So you are going to inject the margin of error. So if you want, okay, ang tanong pala dito, if there is a relationship, yeah, you can still answer relationship, sir. You can answer relationship using now the correlation coefficient, no? The Pearson and the Spearman, but not anymore testing it whether it is significant. The correlation itself is already telling you the output because it is 100% covering the data already. There is no sample done. Did I answer you, Sir Eman? Sir Arman, rather.
Yes po daw, ma'am. Thank you daw, ma'am.
Okay.
Totally kasing hindi tayo makakapag-conduct ng test. So, thank you daw po, ma'am. Thank you for the clarification, Lord.
Yeah, okay. Ito na pala. Thank you. Ma'am, okay. I thought totally casting. Now, you can still make analysis of all. Yun lang, no? Ulitin ko ha, kasi nakita ko rin sa GC kanina.
Okay po. Hello, Ma'am Lars. Nawala ka, Ma'am Lars. Revita, for picture taking na tayo.
Okay.
Ayan na si
Okay.
Lars. Nawala ka, Ma'am Lars.
Bakit wala? My internet is unstable. Ano to? Oh my. Oh.
Hindi na lang tapos mo na yung lecture mo, Ma'am Lars.
Kaya nga. Okay, unstable daw. All right. Sabi niya, your internet is unstable. Okay. Ala, nagpabang. Meron pa bang tanong? Reactions. May tanong?
I think there are no more questions, Ma'am Lars. I think pagdating sa workshop this afternoon, doon sila mas maraming itatanong sa'yo kasi doon na yung hands-on nila. Yung mismong may data na sila. Ma'am, can we,
Ay, nag-raise hand?
nag-raise hand ba,
Ay,
Revita?
hindi ko alam. Tignan mo nga.
Ma'am, I'm not sure. Hindi ko po kasi nakita.
Wait, sandali. I-open ko yung reactions.
Wala naman po.
Ay, wala. Okay.
So,
wala
ay,
na.
nako. If you don't have any more questions, may you please open your cameras for our picture taking.
Sandali, kasi hindi, kasi maano yung camera ko. Agad-agad siyang nag-o-off.
Yan, ma'am. We can
Ayan.
see.
Hindi agad nag-o-off. Hindi ko alam kung bakit. Nag-o-off.
Lars, can we request
Ma'am Caril David.
mo ang iyong slide muna para fully
Yes,
yung...
po.
Okay. So wait. Stop presenting ako. No?
May button po ata dyan, ma'am, na i-close nyo na lang po.
Stop sharing.
Yes po.
Okay? So hindi ko alam kung bakit ayaw yung camera ko. Ayaw ng camera ko, sorry. Ayaw sa naka-ID na
This
na.
document. Sino nagdo-document? Let us know kung mag-i-smile na ba kami or tapos na kami.
Ayaw ng aking camera.
Okay na yan.
Larissa, ma'am.
Okay, Clarissa, tell us if mag-i-smile na kami.
So, may I request everyone po to open their cameras po.
Sayang, ayaw ng camera ko. Ay, naku, I'm using my laptop kasi. Anyway,
Except si Ma'am Lars na lang, not functioning yung camera.
oo, pero at least may ID naman, di ba?
Yes, ma'am, yes.
Palitan ko na lang yung ID ko dyan later. Ayaw ng camera. Wait, ulit. Ulit. Ayaw ng camera. Ino-on ko, ayaw niya. Unable to detect camera. Okay. Okay, so this afternoon we will start at what time?
1:30, ma'am. 1:30 po. Pero we will ask the already. You will be showing them first. Ita-table ba nila, ma'am, from objectives and then the 6 things to consider para makita mo agad kung tama ba yung statistical treatment nila in the end?
Ayan. Most likely, mas maganda kung ganun, ma'am. So,
Yan ang ipagawa natin at 1:30 sa kanila.
now, Dean and company, those of you who have messaged me, no,
No, ma'am. I'm sorry, may
great
kasabay lang.
statistical analysis tool, it cannot be like that only, no? So you will just, okay, you just ask me, ma'am, ano po yung statistical tool? O, ganun kaagad. No, there are factors, okay? So you will not just message. I am willing, very much willing to help everyone, but sometimes you might say na dinededma ko yung message niyo pero hindi ganun kadali na agad ko sasabihin kung ano yung statistical tool. All right, so thank you very much. See you this afternoon. Thank you, Ma'am Ann, Ma'am Jinky. We have a lot who are here. So si Ma'am Lloyd, si Ma'am Glenda, no? All right, so thank you, Ma'am, for joining.
Okay na ba ang picture taking mo, Revita?
Ma'am si Larissa po.
Larissa, okay na ba?
Ma'am, okay na po.
Okay, thank you so much. See you at 1:30 this afternoon. For those who have objectives, it's the best time na check natin kay Ma'am Lars kung appropriate ba yung mga statistical analysis na nilagay natin sa mga papers natin. Thank you so much. See you this afternoon.
Thank you, ma'am.
Bye-bye po.
Bye-bye. Mag-leave na ako, ha?
Yes, ma'am, but we'll just keep this link open po for those who
Yes.
wants to stay.
Okay, sige, ma'am.